This is the wood chip material, the raw material that we use for making the hardwood fiber railway sleepers. It's Seligna, and as you can see from the chip size, it's come from the primary mill at the sawmill, where the roundels have been taken off the logs and the roundels extracted and then milled, and this is the fibre that we're left with for use. This is normally would be burned or disposed of in some other way. It might be ground up further and used for mulch and so on, but 90% of it is burned. Some of it is used in the manufacture of steel for the carbonation of the alloys. This is the secondary milling machine. This is the feeder, and there's an auger which goes up to the mill itself. That is the mill there. It is a prototype, the only one of its kind in the world, and it turns the fibre into the material that we use in the manufacture of the railway sleepers. This is the material as it gets fed into the auger for transport to the mill, and we'll let you see what the final product looks like. This is the fibre as it exits the mill. You can see it's got a very high aspect ratio, and it's absolutely ideal for the manufacture of value-added products. From here, the fibre goes to the mixing plant, which is the unit standing behind there. The black boxes contain fibre ready weighed to go into the mixing area. This is the inlet unit for the mixer. The material is loaded here. It's then sprayed with the polymer from the top, and the mixing takes place inside. This is the discharge side of the mixer. What happens now is the material, having been weighed and so on, goes from here to the forming station and the press. This is the primary press unit. This is where the sleeper material is pushed into the mould. The mould can be seen at the bottom of the press. The cylinders and the handling equipment for the moulds is seen on top. The material is put into the forming station and evenly spread over the area. What's going to happen under mechanized circumstances is that that plenum chamber will be fed by an auger, which will evenly dispense the material into the chamber. Now the sides of the chamber, one side of the chamber is capable of moving, so the chamber moves, and this is the first phase of the fiber alignment which takes place. This will be done mechanically with normal circuit breakers. Okay, now what's happened is the fiber has been squeezed sideways, and it will now be, you must hold that in position, guys. You've got to hold that. You mustn't let this come back. Just, you must hold that in position. This one? Yes. Okay, the material is spread by hand now, but what will normally happen is it will be spread manually, mechanically across the inside of the pennant channel. So the one phase of the fiber alignment is taking place, and now they're going to press the material into the mold. The press is a 460-ton unit and is capable of producing a sleeper every 2 minutes, or 2 narrow gauge sleepers every 2 minutes, or if you like, 1 a minute. The press is a 460-ton unit and is capable of producing a sleeper every 2 minutes, or 2 narrow gauge sleepers every 2 minutes, or if you like, 1 a minute. The mold is now in the press, the fibre is in the mold, and the press has pushed the mold lid closed, and it'll have to wait some time in the mold before it can be released. If we have more than one mold, obviously we can cycle the molds a lot faster than that, but as a prototype we're just leaving it in the mold till tomorrow, and then we'll release the lid and then we'll take out the fibre. Okay, that's the end of this recording. The molds are then brought to this heating unit where they stay for 4.5 hours. Normally they would go to the kiln, which has a very big capacity and can hold many hundreds of molds, but just for this prototype phase we're using this makeshift heating system to speed up the curing time of the sleepers. From the main press, the mold with its sleeper inside it goes to the recovery press. Finished mouldings prior to going to the paint shop. Okay, we are now filming. Okay, this is the team that made these sleepers, and they're proud of the work that they're doing. This is the end of this video. Thank you, chaps. Thank you very much. Thank you, thank you. I'm sorry it's easily as durable as wood without the disadvantages of splitting and drying.
Behind me is a section of track that's going to be removed, and the HM sleepers will be placed in. In the foreground you can see the HM sleepers. On the section of track, which is about 10 meters long, we're going to be putting in about 13 HM sleepers.
This is the 10-ton forklift that we're going to use to lift the tracks. In the foreground you can see the rail that runs down to the steam locomotive workshop. Background you can see some tractors and some warehousing, machine workshops and storage areas. The plan is to remove 14 sleepers from the section of rail and replace them with our HM sleepers and Yati sleepers. The 20mm spacer board can be clearly seen underneath the sleeper, and that will give us the unsupported section. The 3 sleepers in picture will be the unsupported section. Just mind your hands away there. Okay, maak vas. Using a power bar just to tighten down the sleeper clamps. There you can see the spacer plank under the middle sleeper.